Now, as we had discussed in previous lectures about fundamental quantities, their units, along with that we have to discuss one more fundamental part in physics. This is no doubt applicable in chemistry also. This is called as atomic structure. Now, first thing, the existence of atom. In earlier days in India, Acharya Kanak proposed this theory that everything in this universe is made up of small tiny particles, and later on this theory was developed. So his original name was Aulukya, but he was titled as Kanak. Kan means small particle. So he was saying that everything in this universe is made up of very very small particle. He called that small particle as an atom. But still in Western world there was debate about existence of atom, and ultimately Dalton proposed out theory about atom. In modern days, a German glass blower means what? A man or person who is able to blow glass and convert it into some article. So German glass blower, his name was Gessler. You can pronounce it Gessler also because spelling starts with G. So that Gessler produced a tube that is called as hard glass tube. Now here we are not only discussing atomic structure, along with that certain important principles in physics we are discussing. Now question is that what is the importance of word hard? Why we are not saying glass tube? He was able to produce hard glass tube which is having 2 electrodes in that. We have to discuss why that tube was hard. Let us consider the pressure. In previous lectures only we have discussed about pressure. What is pressure? Force applied in perpendicular direction upon a unit area, a definite area. Whatever the force is applied in perpendicular direction, that is called as pressure. Now, in general words, we are saying that atmospheric pressure, that is pressure exerted by atmosphere, that is 1 atmospheric pressure at sea level. Let us discuss this concept. The instrument which measures atmospheric pressure, that is called as barometer. Now, schematic diagram of barometer. We are considering this is some vessel which is filled with mercury. Symbol of mercury is H. So this vessel is filled with mercury. In previous lecture we have discussed why mercury is used. Try to recollect that term. Mercury is having very high density. Now you are aware what is density. Density is equal to mass upon volume. So mercury is having very high density. Mercury is not sticking to glass, and mercury is in liquid state at room temperature. Now one hard glass tube. Again I had to use that word, that is hard glass tube. So one hard glass tube we have to take which is filled completely with mercury. And now this tube we have to invert. The length of tube should be 1 meter. Now we have to invert this tube over here. Now it is obvious that because of gravity this mercury should come down. But you are aware that here also we are filling out mercury. Now the atmospheric pressure is acting over here. Actually it is acting everywhere, but I have to show that it is acting here. And so as mercury starts falling down, this pressure opposes out that pressure, that fall of mercury, and ultimately a state that is called as equilibrium is established. Equilibrium means what? The force exerted by this mercury and pressure, that is balanced out. If you measure this length is 760 mm of mercury. Now you are clever, you can calculate immediately in terms of meter, we can go by this way, 760 into 10 to the power of minus 3 meter. Try to recollect millimeter to meter, we have to multiply by 10 raised to minus 3. Meter to millimeter, we have to multiply by 10 raised to 3. So here 760 into 10 raised to 3, that means 76.0 into 10 raised to 3, 10 raised to minus 3. That means I have to shift decimal 3 places towards left. So answer is 0.76 meter. So this length is now 0.76 meter, especially if you are at sea level. So this pressure is called as 1 atmospheric pressure. So what is 1 atmospheric pressure? Pressure exerted by atmosphere at sea level. Or in terms of this meter, we can say it is 760 millimeter of mercury. Now here, this place is practically vacuum. Why there is vacuum? Because no bubbles are now going out. So there is no air. May be possible, traces of vapors of mercury may be there. But practically speaking, we are saying there is vacuum. Torricelli pointed out this vacuum, so we are calling this as Torricelli's vacuum. So this is Torricelli's vacuum. This barometer was also designed and developed by Torricelli. Now this mercury level is 760 millimeter. This pressure is called as 1 atmospheric pressure. Now suppose you are moving at higher altitude, that means away from sea level, we are moving higher, higher and higher. Then you will find that mercury levels start decreasing. What is the reason? Atmospheric pressure decreases. So as we move away from the surface of earth, the atmospheric pressure decreases. That means at high altitude, atmospheric pressure is lower. So this way you can find out the lowering of mercury level with respect to height. Same way, suppose you are moving inside the surface of sun. Say you are digging out a huge well, and in that well you are moving in. Then you will find that mercury level will start increase because atmospheric pressure will increase. Now this pressure is called as 1 atmospheric pressure. Obviously, this 1 atmospheric pressure is 760 mm of mercury, but in our normal term, we are calling this as 101.325 kilonewton per meter square. In previous lecture only we have discussed, it is given in terms of Newton per meter square. Kilo stands for 1000 or multiplier of 10 raised to 3. Now we can calculate 101.325. I have to shift out decimal. Why? Because this is into 10 raised to 3 Newton per meter square. Decimal is here. Now I have to remove this decimal. 10 raised to plus 3. That means we have to shift decimal 3 places towards right. And so we are getting figure as 1, 2, 3. That means simply I can write this way. 101.325 Newton per meter square. What is Newton? You are aware, from force we have developed this unit. So what is the definition or what is the formula for force? Force is equal to mass into acceleration. So unit of mass is kilogram and acceleration is meter per seconds. Now just be careful. Just observe whatever we are calculating here. So I am replacing this Newton by this way. So 101.325. What is the pressure? That pressure is equal to 101.325 kilogram meter per second square. This much pressure is there per meter square area. Now imagine that this is the person having a sheet which is having length 1 meter and breadth also 1 meter. So what is the area of that sheet? That is 1 square meter. On that, atmospheric pressure is acting out. Now as I am making area as 1 square meter, this term get reduce. What is acceleration? Here, this is because of gravity. So I should replace A by G. G stands for gravitational acceleration. Its general value we are considering 9.8 meter per second square. Whenever we are discussing acceleration in detail, at that time we will go in detail. Now I will here consider approximately this value is 10 meter per second square. 9.8. For our sake of calculation, simplifying, I am taking this as 10. That means whatever the pressure is equal to force acting on unit area. That unit area I have discussed. So divide this by 10. Now pressure is equal to force upon unit area. Now we are considering area equal to 1 meter square. Just observe, this area is 1 into 1 meter square. Therefore pressure is equal to force. Now force is equal to mass into acceleration. Therefore mass is equal to force upon acceleration. Now we have substituted as A equal to G, that is equal to 9.8 meter per second square. So just consider 10. And what is the value of force we have discussed? That is 101,325 kilogram meter per second square. Now forget of this unit. This is the value of force. We have to calculate mass. So value of force upon acceleration. So acceleration is 10. So this is 101,325.0 divided by 10. 10 means what? 10 to the power of 1. So whenever these type of questions are there, carry out this way. 101,325 into 10 to the power of minus 1. And you are aware now 10 to the power of minus 1. That means we have to shift decimal one place towards left side. So 101,325. Take it as it is. Shift out decimal one place towards left. So we are getting answer as this. Unit is kilogram. What is the meaning of this? Suppose we are holding out a flat surface which is having area 1 square meter on our head. We are lifting out the weight that is almost equal to, why almost equal to, actually greater than this, but that is almost equal to 101,32.5. That means just try 10,132 kg. That's why we are going into this calculation. These calculations are very much interesting because right now we are lifting out. Suppose you are staying at sea level. That means you are lifting out 10,132.5 kg weight. So even much more greater than any weightlifter. We can lift out 100 kg, 200 kg, 300 kg. Right now I am here and there in Mumbai. Mumbai is at sea level. So right now I am lifting out 10,132.5 kg. What is the difference between weightlifter and myself? Weightlifter also lift out this much weight plus whatever 100 or 200 kg is lifting, so that he is no doubt greater. Anyway, so this is the thing. That means approximately weight of 3 elephants we are lifting right now. This is the huge pressure. Now just imagine, suppose a glass tube is there and on that 3 elephants are pushing out. What will happen to that glass tube? That's why we require hard glass tube. Whenever a glass tube is there, say this is the glass tube, this is having open end. So atmospheric pressure is acting on this glass tube from this side. The same way the balance is carried out in any open vessel. But the moment you connect it to evacuating pump, that means we have to create vacuum here. The moment pressure start decreasing from inside, the external pressure become dominant and movement of particle will take place in downward direction. As a result, this tube will break down. And so, in order to resist that, this tube must be hard glass tube. So, This is the reason we are using hard glass tube. Now what is the peculiarity of this Gessler? He produced out this hard glass tube which is connected with electrode. Now if you want, you can take this down calculations, all these calculations. Till that, pause this video and then observe next. This is the reason that at high altitude many people are having respiration problem, because those who are staying at sea level, they are having habit of breathing in very high pressure. No much activity is carried out easily because external pressure is very high, so respiration is carried out very easily. Once you are moving to high altitude, say for example in Himalaya, especially on the plains of Ladakh, if you are moving, you will find this difficult, that people from lower altitude, they are not able to carry out breathing very easily. The reason is that at that height of say 4,000 meter, 5,000 meter high, the atmospheric pressure is low, and we have to mechanically take that inspiration. We have to inhale that oxygen with pressure, because the external pressure is low, and therefore many problems are there, especially the person from lower altitude is moving to higher altitude. Therefore, even in trekking also, treks above 5,000 meter high are categorized in different way. Under 5,000 meter, things are different. Above 5,000 meter higher altitude, the things are different. Even oxygen level is also very less, and atmospheric pressure is also less. You can check out that boiling point of water also decreases at high altitude because of low atmospheric pressure. Anyway, this is about the atmospheric pressure. Now, this is clear for you that why we are taking hard glass tube. Now, one thing I want to make clear, that my drawing is not good, and on this type of whiteboard this is not at all good, but try to understand. No doubt we can animate, but I am against that type of animation. So just try to understand the concept first. These drawings are called as schematic diagram. What is the meaning of schematic diagram? Diagram which is drawn to explain certain things. This actual tube may not be like this, but we are giving some scheme. Schematic diagram is there. Now, this is that Gessler's hard glass tube fitted with these electrodes. Electrode is made up of a metal and having connector outside. So this is metallic disc, and which is connected to connector outside. This is the provision, so that we can connect this to evacuation pump. Evacuation means I have to create here vacuum. I have to remove air from this, so there will be evacuation. Now, what experiment is carried out by scientists that connect this to evacuating pump? That means atmospheric pressure inside this tube will decrease, and connect it to high voltage of electricity. I am not making circuit diagram perfect. We are interested only in part of atomic structure. So whenever we are discussing this in physics, this electricity, etc., that diagram will be perfect here. Now here we are making two electrodes. You are supplying here high voltage. They say this is negative electrode and this is positive electrode. Now negative electrode is called as cathode, and positive electrode is called as anode. We are increasing out EMF, high voltage. Voltage means what? Actually we are increasing out EMF. EMF stands for electromotive force. So we are increasing out EMF and we are decreasing out atmospheric pressure. Or in simple language, we can say we are decreasing out atmospheric pressure and we are increasing out electrical pressure. Not scientific. Now, what is the result of that? certain invisible rays are produced by cathode. When there is almost vacuum in the tube and electrical pressure is very high, you will get here certain invisible radiations coming out from cathode, and they are striking on this side of tube, and therefore this side of tube start glowing with green color light. We have to perform this experiment in dark room. So this portion will start emitting green color light, or this tube will start glowing because of certain invisible radiations. Here we will not able to observe. These radiations are coming out from here, but you are not able to observe here. But they are striking on this glass, and glass will start emitting radiation. Now, this is because of radiations produced, some invisible radiation produced in the tube. Then scientists detected these invisible radiations are produced by this negative terminal, and so negative terminal means cathode. So these radiations are called as cathode rays. So this way, now I can show this is schematically that cathode rays are coming out from cathode. Now certain substances are there. They are having some characteristic, like high energy invisible radiations are bombarded on that. These substances start emitting visible light. One of that substance, if you are aware, this is called as zinc sulfide, ZnS, not sulfate. Okay, suppose I have to write down sulfate, then this is ZnSO4. I don't want to write down sulfate. So keep in mind sulfate means SO4, whereas sulfide means S. So this is zinc sulfide. What is the color of this compound? Just try to guess. If you have learned in chemistry, all compounds of zinc are colorless, or say white in color. Certain reasons are there, we discuss in chemistry, but zinc gives almost all variety of compounds in white color. So zinc sulfide, what is the color? You can say white. Have you observed this zinc sulfide? Answer is that yes. In whatever tube lights we are observing, that zinc sulfide is present in tube light. Due to bombardment of invisible radiation, zinc sulfide starts emitting white color light. That's why we can able to observe this white light from tube light. Now, scientists carried out certain experiments on these cathode rays. Say for example, this tube is covered by zinc sulfide from inside part, and they observed by placing some external magnetic field or external electric field. Now here I am showing electric field. So external electric field is applied over here. It was surprising to know that cathode rays also change out their direction and they move towards positive plate. Please keep in mind, this is anode, but this is internal, whereas external is outside the tube. So towards external positive plate, cathode rays get attracted. That means cathode rays must have negative charge. Second, internal cathode I can place anywhere. Say I can place cathode over here, I can place cathode over here. It is always found that direction of cathode rays is perpendicular to the surface of cathode. It is not depending upon the position of anode. So there is no question of anode now. Anode must be there in the tube. Now, scientists carried out another experiment. They fixed out some track in this tube. Again, I want to remind, this is schematic diagram. Don't ask me how that track is floating here. This is schematic diagram, and they fixed out some wheel over here. It is found that the production of cathode rays will rotate out this wheel from this position to this position. So it is moving from here to here as cathode rays are generated. Same way, suppose I am inverting out the terminal. I am making this as cathode and this as anode. Then the direction of wheel changes. It will move from here to here. Now, that means cathode rays are capable of generating force. Force, you are aware, is equal to mass into acceleration. We have to put arrow marks over here. Now, cathode rays are producing acceleration, velocity is there. But if mass is zero, then force produced by cathode rays must be zero, which is not. That means what? Cathode rays must have mass. So this is the reason that cathode rays are having mass as well as cathode rays are having negative charge. Now, Sir J. Thomson carried out this experiment. According to Sir J. Thomson, he was able to find out first E by M ratio. What is E by M ratio? E means charge and M means mass. So charge to mass ratio he was able to calculate. Then he used different element as cathode. Variety of metals he tested for cathode, and every time he find out E by M ratio. And surprising to know, always E by M ratio found to be constant. That means, irrespective of metal, emitted cathode rays are having same or similar characteristic with respect to charge and mass. That means, all type of metals or whatever the metals used by Sir J. Thomson, they are possessing same type of particle. Sir J. Thomson termed this particle as electron. So this is the discovery of first subatomic particle. What is subatomic particle? The particle which is present in atom, that is called as subatomic particle. So this way Sir J. Thomson was able to discover electron with respect to cathode ray tube experiment. Now you are aware that electrons are having negative charge. Atom is electrically neutral, whereas atoms are emitting negatively charged particle, that is called as an electron. How it is possible? That means equal and opposite charge must be present in the atom. That equal and opposite charge particle, that is called as proton. So according to Sir J. Thomson, he put forward some atomic model. According to this model, atom is essentially a sphere of positive charge, and negatively charged electrons are embedded in between. This model is called as watermelon model of atom. Why we are calling this as watermelon model? We have to consider this positive sphere like watermelon, and these negatively charged electrons, they are seeds embedded in between. So this is called as watermelon model of atom. No doubt, why atom is spherical in nature? The answer lies over there. Why Earth is spherical in shape, Moon is spherical in shape, Sun is spherical in shape, and so on. Sphere shape is important. At given mass, minimum surface area is given by sphere. So whatever the mass, what is the surface area, minimum surface area possible? That minimum surface area possible is equal to sphere area. And so for given mass, in order to get minimum surface area, the particle must have spherical shape. And so he considered atom as spherical in shape. No doubt, this model was discarded. So many things we are not able to explain on basis of this model. Number one, the origin of spectra. Here, no doubt, we are discussing about atomic structure, but along with that, variety of principles and concepts in physics we are discussing out over here. So, what is spectra? Let us discuss the part what is spectra. There are different theories for light. What is the exact nature of light? According to Newton's theory, that is called as Newton's corpuscular theory, light is made up of tiny massless particles. Whereas according to wave mechanics, light is made up of wave. We are concentrating here on wave theory of light. Consider a small pool. Let us say this is the pool. To that center, we are dropping out a stone. You will find that certain concentric rings are coming out from that pool and they are propagating towards the periphery. Now, these concentric rings we are calling as waves. So this is the nature of wave. Now, just place out a piece of thermocol over here and again drop that stone. You will find that waves are coming out from center, but piece of thermocol is not moving towards this periphery. This thermocol piece will vibrate only at this position. It will move up and down. This is something different. Say I am making this angle as this way. From side we are observing. So here wave is produced. So this is the waves. We are having concentric rings. From side view we can observe like this. This is called as crest, whereas this is called as trough. So this is the wave. The part which is moving upside, that is called as crest. The part which is moving downside, that is called as trough. Now, piece of thermocol is somewhere here. So you will find that piece of thermocol will oscillate in this direction. It will move up and down in this. Now here, the direction of wave is this, whereas direction of vibration is this. These two directions are perpendicular to each other, and therefore we are calling this as transverse waves. What is the meaning of transverse wave? The propagation of wave is in different direction and particle oscillates perpendicular to that direction of propagation of wave, and therefore these waves are called as transverse waves. Now we have to find out, or we have to discuss certain wave characteristics. We are making some graphical representation. I am drawing a wave. Consider all these are of same size. Now this is called as crest, whereas this is called as trough. So this is crest, this is trough. This is the mean position. That means before disturbance is carried out, the position is this. After getting disturbance, we are getting formation of wave. Now this is the maximum displacement from mean position. So this is called as maxima. This is the minimum or lower side displacement from position. So we are calling this as minimum. This is also actually maximum displacement, but towards downside. So we are calling this as minimum. The maximum displacement from mean position. So mean position and maximum displacement, this distance is called as amplitude of the wave. So wave characteristic we are discussing, this is crest, this is trough. The maxima, minima. Maximum displacement from mean position, this distance is called as amplitude. Same way this is also amplitude only. Whatever amplitude is here, that same amplitude is here. So this is called as an amplitude of wave. Now what is one single wave? Say from here to here, this distance is called as single wave. So this is called as mean position. This is one more mean position, and again there is mean position. So one wave means what? One crest plus one trough. Look here, one crest plus one trough. That is called as one wave. So what is wavelength? So I have to check this distance. This distance is called as wavelength. Wavelength is denoted by this Greek letter that is called as lambda. So this is wavelength. This is denoted by lambda. We can say reverse wave y, something similar to inverted y. So this is lambda or wavelength. Now how we are going to define what is wavelength? Wavelength is distance between alternate mean position. So this is first mean position, I am not considering second. The third, that means one is left, So this is called as alternate. So distance between alternate mean position is called as wavelength. Now you are aware now what is the first characteristic we have discussed? Amplitude. Second characteristic we are discussing, that is wavelength. Wavelength is denoted by letter lambda. Now this is also maxima, this is also maxima, this is minima, this is also minima. This lambda, if you measure, you will find that between two maximae also the same distance is there, and between two minima there also same distance is there. So we are defining wavelength as distance between alternate mean position or successive means one after another, so successive maxima or successive minima. Again remember, what is wavelength? Wavelength is distance between alternate mean position or successive maxima or between successive minima. So this is called as wavelength. Now next property we have to discuss, that is the frequency of this radiation. What is frequency? Number of waves passing out. What is one wave? One crest plus one trough. That is called as one wave. Number of waves passing out in unit time is called as frequency. I am revising. Number of waves passing out from a particular point in unit time. Now you are aware of unit of time, we are considering in second. So unit time means 1 second. So number of waves passing from particular point in 1 second is called as frequency of that wave. Now frequency of that wave, that is denoted by letter nu. These all Greek alphabets are there. So frequency, what is the letter we are using here? That is nu. What is nu? Number of waves passing out in a particular point in unit time, that is 1 second. So how we are going to define frequency? Or suppose we have to find out unit, then simple thing, this is called as one wave, or rather here we can call one cycle. So 1 cycle per second, 2 cycles per second, 3 cycles per second, like that we can find out the frequency. So what is unit of frequency? Cycles per second. Now in honor of scientist Hertz, we are giving this unit as Hertz. So what is 1 Hertz? 1 Hertz is equal to 1 cycle per second. That is called as 1 Hertz. So unit of frequency, that is we are giving by letter Hz. That is Hertz. Hertz means cycles per second. Now you are aware that in case of wave, there is amplitude, there is wavelength, there is frequency of that wave. You are aware that radiation is also having some energy. Don't believe? Okay. Go and stand in sunlight. You will find that whatever sunlight is giving heat, that is also a form of energy. You can keep photoelectric cell. That is, sunlight is converted into electrical energy. That means light energy is converted into electric energy, means light is having energy. You are aware of certain instruments, equipments also, like microwave oven. That is heating out with help of microwave. So now it is, keep in mind that every radiation is having certain energy associated with it. No doubt, energy may be less or high, but that is associated with radiation. So next concept we are discussing, that is energy. Energy is denoted by letter. Now with this diagram, it is very clear that as lambda increases, lambda means wavelength. So as wavelength increases, the number of waves passing through particular point will decrease as long as velocity of that wave is constant. Now keep in mind that velocity of light is constant. So we are determining the another factor, that velocity of this wave. So velocity of light, that is constant, and we are determining, we are denoting this by letter C. So C stands for velocity of light. So as long as velocity of light is constant, when velocity of light can be changed? Yes, we can change out velocity of light, especially when light moves from lighter medium to denser medium, its velocity get altered. That means as long as velocity is constant, wavelength if increased out, the number of waves passing through particular point will decrease. That means suppose I have to give relationship between frequency and wavelength, then frequency is inversely proportional to wavelength. That means if frequency increases, wavelength decreases. If wavelength increases, frequency decreases. So this is called as inverse proportion. But anyhow, we are not able to calculate on basis of this proportionality sign. So how we are removing proportionality sign? That frequency is equal to, I have to remove this and I have to keep some constant into lambda. So substituting this proportionality sign by equality sign and k, we are able to substitute, we are able to make equation. Now this k is constant. Now here particular constant is turned, here we are giving this constant named as c. Why? We have discussed, as long as velocity is constant, the frequency and wavelength, they are inversely proportional. So I am giving this constant as c. So nu is equal to c by lambda. So this is my equation. So I am writing here, first equation we are giving here in terms of wave, that frequency is equal to c by lambda. Then it is found that energy of radiation is directly proportional to frequency of that radiation. So energy is directly proportional to frequency of that radiation. Therefore, energy is equal to, I have to remove this sign. So is equal to some constant. Now here we are calling this constant as h. That is called as Planck's constant. So energy is equal to h into nu. So this is my second equation. I am writing over here, energy is equal to h into nu. What is h? H is called as Planck's. Now in this equation we will discuss, this is c. C is velocity of light. What is velocity of light? We are considering this velocity in vacuum. For standard we are considering that is in vacuum. So for general purpose we say it is equal to 3 into 10 raised to 8 meter per second. Actual value is different. It is 2.99 something. But for general purpose we are saying it is 3 lakh kilometer per second. That is equal to 3 into 10 raised to 8 meter per second. Another constant we are discussing here, that is h. H is called as Planck's constant. The value is 6.626 into 10 to the power of minus 34 unit in joule second. Now from our side you have to by heart these values. Sometimes they are providing, but otherwise you can by heart these types of values. So whenever we are discussing some constant, you have to by heart these values. So we have two equations, nu and e. I can combine these two equations because I am having value of nu. So I am substituting value of nu over here. So my third equation, that is E is equal to h. What is the value of nu? C by lambda. So h c by lambda. This is my third equation. Actually by combination of equation 1 and 2 we can able to derive this, because nu is equal to, from equation 1, nu is equal to c by lambda. I am substituting just value. So we are getting this nu is equal to c by lambda over here, and answer is E is equal to hc by lambda. That means h is constant and c is constant. I am removing these two constants. We are getting equation that energy is inversely proportional to wavelength, and therefore we can say as wavelength increases, energy decreases. As energy decreases, wavelength increases. Alright. So this is about the certain characteristics of, as there was question, what is spectra? Whenever we are passing white light through prism, we are getting it is scattered in 7 different colors. So that is called as spectra. But afterwards it is found that variety of invisible categories of lights are also there. Here I am giving you that idea. So we are constructing some chart, that is single axis chart. This is with respect to increasing energy. That means with respect to increasing frequency also. So here we are getting minimum frequency or minimum energy. Here we are getting maximum frequency or maximum energy. Same way, you are aware that wavelength is inversely proportional or energy is inversely proportional to wavelength. So here I am giving wavelength chart. Here we will get minimum wavelength, here we will get maximum wavelength, as they are inversely proportional. So highest energy radiation we are giving as gamma. In some books they are mentioning cosmic rays, but here whatever the discussion we are considering gamma rays as highest energy radiation. Then another radiation type is there, that is called as X radiation or X rays. Third type of radiation in this series, that is called as vacuum ultraviolet radiation. These radiations are having existence only in vacuum, therefore they are called as vacuum ultraviolet. Then ultraviolet radiation. We are aware of ultraviolet radiation, and especially in this modern world, especially in terms of cosmetic, again and again we are using this word ultraviolet, ultraviolet. In case of computers and television, we are considering that same as ultraviolet radiation. Then next radiation, that is called as violet radiation. From here we have to say all colors of rainbow. So violet, indigo, blue, green, yellow, orange and red. All these colors, they are called as Vibgyor. This is the only visible range. We can able to visualize only these radiations. UV, ultraviolet, X-rays, gamma rays, we are not able to visualize. We are not able to observe. Then henceforth, next invisible radiation, that is called as infrared, infra below. So ultra beyond. So beyond violet and below red. So this is ultraviolet, violet. Same way red, infrared. Then it is called as far infrared. Then microwaves. You are aware of microwave oven. And lastly, radio waves. Now how to keep in mind? We can go that highest energy radiation is gamma rays. If question is asked between gamma and cosmic rays, then obviously cosmic rays. Then gamma rays, X-rays, vacuum ultraviolet, ultraviolet, violet. Just listen, V, U, V, U, V and V. So decrease out one letter, V, U, V, U, V, V. Then Vibgyor, that is the color of rainbow. Then after that there is last color red. Here infrared and far infrared. So R, IR, FIR. Then microwave and radio waves. Now what is the source of gamma rays? Gamma rays are produced by certain elements. They are called as radioactive elements. So from radioactive elements we are getting very good quantity of gamma rays. The desired frequency, only one radiation is not there. Variety of frequencies, that means variety of energy radiations are possible in gamma rays. So they are obtained from radioactive element. But in the space, gamma radiations are obtained from variety of stars and planets. The best source of gamma rays we can consider here, that is very near to Earth, that is gamma rays source is moon. Don't consider moonlight is very cold in nature, that is cold on Earth, but in actual practice moon is giving very good amount of gamma rays. No doubt gamma rays are absorbed in atmosphere. So suppose we are observing from Earth, then moonlight is very cool because gamma rays can travel hardly distance of 10 to 12 centimeters in atmosphere. Whereas you are aware, till 400 kilometer from Earth, atmosphere is having existence. Whereas gamma rays are traveling just distance of 10 to 12 centimeters in the atmosphere. So gamma rays from moon, they are not coming on Earth. Gamma rays emitted by sun, they are also not coming on Earth. Sun is also emitting gamma rays. But as compared to moon, sun is blurred or dull in emission of gamma rays. No doubt, Earth is not emitting that much gamma rays with compared to moon and sun. Now next source, next radiation, that is X-rays. Wilhelm Conrad Röntgen, so simply according to spelling I must pronounce as Röntgen. So Wilhelm Conrad Röntgen able to discover this radiation, and so he termed as X-rays, unknown radiation for him, so he termed as X-rays, like algebra. So that is called as X radiation. In some book it is written as Röntgen radiation, but himself, Röntgen was against giving his name to that radiation. He says this must be termed as X-rays only. So this is called as X-rays. Variety of X-rays are there. We are just giving only small list here, so we are denoting X-rays. What is the source of X-ray? That is called as X-ray tube. From X-ray tube we can able to generate X-rays. Now you are aware of cathode rays. Suppose high energy cathode rays are suddenly stopped by hard metal, it is producing X-rays. So very good source of X-ray is X-ray tube. But another source is there that is very close to us, and right now it is in front of you. Suppose you are using cathode ray tube, television or monitor, then that can be a source of X-rays, because whatever television, the old color televisions, they are made up of cathode ray tubes. If cathode rays are suddenly stopped, they are producing X-rays. So in old TV set, many times a coil is there that is called as EHT coil, extra high tension coil, that can generate high EMF as it getting old and old. So immediately it will start producing X-rays. X-rays are having comparatively greater range in atmosphere. They can travel for 12 inches to 18 inches. Keep in mind, I am talking in terms of inches now. For gamma rays, we are talking in terms of centimeter. Here I am talking in terms of inches. So approximately we can consider 30 to 45 centimeters is the range of range of X-rays in atmosphere, and that's why one should not sit in front of television, especially color television, or beside the television. We should sit or stand at least 2 feet away from television set. This is called as X-ray pollution, especially in the cities. Then these radiations are produced on sun. For ultraviolet radiations, we are aware that ultraviolet bulbs are there, hydrogen lamps are there. They are producing ultraviolet radiation. These ultraviolet radiations are used to distinguish between fake notes and true notes. That is, the ultraviolet bulbs are there. Then from visible light, from violet to red, we can produce on earth very easily that tube light, that is giving variety of mixture of this. We can just separate out with help of prism or with help of even our CD. Just try to observe CD, just move here and there, you will be able to observe variety of colors on that CD. That is because of scattering of light. Then infrared bulb is there, from that we can produce infrareds. Then from klystron tube we can produce microwaves, and radio waves are produced from induction coil. So these all types of radiations are produced on Earth. We can able to produce these radiations on Earth, except this. Now certain stars and the objects present in space, they are also producing this variety of radiation. NASA and other research associations, they are associated with it. They are having telescopes, especially which will work on particular region of the spectrum. Say Chandra X-ray Observatory, on behalf of Indian origin scientist Chandrasekhar. This observatory is termed as Chandra X-ray Observatory. That is there to detect X-rays from various sources in the space. Why we have to send these types of observatories in space? Because X-rays are absorbed immediately in atmosphere. So these telescopes or these observatories are set up in the beyond the atmosphere. That means in the space we are setting out these. So Chandra X-ray Observatory is there to observe X-rays. Then Hubble telescope is there that will work on visible range of light. Then on Earth surface we are having certain telescopes, that is radio telescopes. In India, in Maharashtra, near Narayangah, one such huge radio telescope is there. So these radio telescopes are built up on Earth's surface. Reason is that radio waves are not easily absorbed by atmosphere. The phenomena or fundamentals is very simple, that as energy is higher, radiations are absorbed fast in atmosphere. As energy associated with radiation decreases, they are not easily absorbed. Now simple question for you. You can think over. You are having spectra in front of you, and I hope in between the lecture you must have paused the lecture now and you have taken down this spectra. So you can answer very easily of this question. Why red color is used to indicate danger? I am revising the question. Why red color is used to indicate the danger? Why not violet color is used to indicate the danger? Try to find out answer yourself first. Till that, pause this video. If you are able to guess the answer from spectra, all right. Not, listen. Just now we discussed it is associated with energy. More the energy, less the range. Say gamma rays are having range of just 10 to 12 centimeters, whereas X-rays are having range of 30 to 45 centimeters in atmosphere. Like that, as energy decreases or say wavelength increases, the absorptivity of radiation decreases in atmosphere. That's why X-ray observatory is there in the space, whereas radio wave observatory that is there on the surface of Earth. This is the difference. Okay, so now just observe, violet color is having greater energy, that means less wavelength, whereas red color is having lesser energy, that means more the wavelength. So as red light is having more wavelength, that means less the energy, it can have longer range, and from long distance one can visualize red color light. Danger must be indicated from distance, and therefore red color is decided, red color is indicating danger. I am revising, as energy of red color is very very less, or whatever the visible light, I am not saying invisible. In case of visible light, if red light is having minimum energy and maximum wavelength. So it is having greater range. So most dangerous object is denoted by color red. Less danger is indicated by orange color. Still less danger should be indicated by yellow. But there is confusion between yellow and orange color. In order to avoid that, we are considering this as green. And so these types of signals are marked. First number, highest level of danger red, second level of danger orange, that means less danger, and green means what? You can move now. So minimum danger is indicated by higher wavelength. Suppose I am indicating violet color as danger color, then it is not visible from longer distance. The reason range of violet light is very less in case of visible light. Now come to the point spectra. I am giving you an example. We have to take piece of iron. Is it hot or cold? Answer is that on earth every object is hot. We have discussed what is the minimum possible temperature in this universe, that is minus 273 degrees Celsius. At that temperature we are calling that as cold temperature. If object is having greater temperature than minus 273 degrees Celsius, then we have to consider it as hot object. And every object which is not cold, that is emitting infrared light. So infrared light is emitted by every hot object. So at present I am having piece of iron. Say in Mumbai, room temperature we have to consider as 25 degrees Celsius. 25 degrees Celsius, that means 25 plus 273, that is equal to 298 Kelvin. Object is cold when temperature is 0 Kelvin. Again keep in mind, don't read OK. Temperature is 0 Kelvin, then we have to consider that object as cold. If temperature is 298 Kelvin, that means it is much more hotter object. And so piece of iron will emit yellow color, emit infrared light. Why this piece of iron is emitting infrared light? We are not able to explain on basis of Sir J.J. Thomson's atomic model. Now still we can increase out temperature of iron rod or iron piece, heat out. You will find that it will become more and more hot, but it is not emitting any visible light. This is emitting only infrared, but of higher frequency or higher energy infrared light is emitted by that iron piece. Ultimately, you will find that it is going to turn into red color. We are calling that as red hot iron. Red hot means what? It is now starting emitting red light. Still heat out, you will find it will give yellow color light, orange, yellow. Step by step temperature will be increased, and color or wavelength or energy, that is also altered. So why this particular object is emitting different wavelength, that means different spectra, is not explained on basis of on basis of Sir J.J. Thomson's atomic model. This is the drawback of J.J. Thomson's atomic model. The important drawback we have discussed, but by discussing this important drawback, we have discussed a part that is very, very essential, that is part of spectra. So we have discussed this part of spectra. Now you are aware what is the spectrum. So we can discuss the next part, disciple of Sir J.J. Thomson, that was Sir Ernest Rutherford. We have to discuss now theory or atomic structure designed by Sir Ernest Rutherford. So we have to carry out now experiments, that is called as Sir Rutherford's experiment, and then we are discussing out atomic model proposed by Rutherford. Of course, that is in next lecture.